So that's how they've overcome abrasion erosion, is by making both parts of the system virtually equal strength. There's no sense throwing a high abrasive resistant material. If you do industrial floors, the old technology was to throw on a shake hardener, they called it. The finishers would throw on a real hard rock on the surface and try and work it into the surface with their blades as they finish the concrete. Well, that's fine, the rock's real abrasive resistant, but you're still burying it in 4,000 PSI mortar. And that's the stuff that's going to, it's the weak link, it's going to fail first, not the strongest link. And once the weak link fails, then everything else starts to fail in the system. So the whole idea is to make a system that doesn't have any weak links, which is what the Corps of Engineers does. I say dams, waterways, southern Illinois here near Paducah, they're doing the lock and dam there across the Ohio. All of that concrete, underwater concrete, is silica fume concrete, Bureau Rec, any waterways. This next little segment here on our crime construction site investigation, part of the handout, the 2 pages that y'all took from up here, are talking about this Hetch-Hetchy water system. We're going to learn a little bit about California sitting here in eastern Illinois. Anybody been to Yosemite, California? Go out there at least once in your life. This is a, no it's not. Can you move that book, please? This is a map of the area that we're going to be talking about here. The handouts, this Bay Area water system, what they do is they capture the water in the Sierras from the snowmelt to feed all the populations of people along the coast. California is basically a desert. Once you get off the mountain range right here on this side or this side, which is Death Valley in Nevada, and there's nothing out there, is basically a desert. And the only way they can support all those people out there is to collect every bit of water in the mountains. I think there's only 3 rivers in California that actually flow freely to the ocean. And that's up in upstate up here, where they still have a lot of salmon and steelhead and things like that run, so they still keep those open for those reasons. But otherwise, every other river in California is captured for its water, whether it's irrigation or for people. And this is part of the system here. The Bay Area water system operate in Yosemite Valley, which this is a shot of one of the monuments in Yosemite Valley, actually called Half Dome. A little background on Yosemite. John Muir on the right, through his efforts and without anybody in Congress actually seeing Yosemite, Congress made it a national park, the very first, I think first national park.
I think I'm related to him.
Really?
John Muir, yeah.
Really?
Mm-hmm.
One of my heroes. His grandson is still real active in the Sierra Club and things like that. Yeah, yeah.
My uncle is somehow related to him, through, because my last name's Muir too.
Really?
So, yeah.
Wow. Wow.
California Quarter too.
Wow. What's that?
He's on the California Quarter, the new
Yeah.
California Quarter.
Yeah. Hey, I've climbed his mountain, named after him. Anyhow, his efforts in lobbying in Congress and everything, they made this piece of land a national park, and then Teddy Roosevelt went out there to show them around. But Muir was very active in trying to keep this wilderness. And in 1913, the Bay Area people decided that they needed water, and this was a good place for water. So they created this Hetch-Hetchy dam, which Hetch-Hetchy is a reservoir. Excuse me. Hetch-Hetchy is actually the title of that paper that I handed out to you. It's actually a canyon a couple miles north of this valley that we're looking at here. And they literally dammed up that whole valley and filled it up with water. There's one right next to it, this Yosemite Valley, that people from all over the world go to visit. It's a national park. It's the place. You have to go there once in your life. It'll take your breath away, as that photograph shows. But if you go a little bit north of here, up here, the exact same valley's dammed up and filled with water. Muir fought so hard to stop this in 1913 that after they passed the law to dam it up, he died 2 months later, losing that battle, losing the Hetch-Hetchy battle. Anyhow, to give you some perspective of what this valley looks like, This is El Capitan, one of the mountains where people climb it and die. This is actually the Pertunas Towers superimposed on it. That's the tallest reinforced building in the world. It's in Singapore. 3/4 of a kilometer high, something like that, 120 stories. Sean Connery and Catherine Zeta-Jones, that one movie with the catwalk between the building up here, that's the building. That's superimposed on this rock, 4,000 feet, one rock, from bottom to top. You stand back and it's your whole field of vision. So it's a pretty impressive place, and you can see on this map that this is the valley where El Capitan and Half Dome, this is the valley here that is in place that we showed pictures of, and this is the Hetch Hetchy Valley up here, and you can see it's all blue. It's all a dam that dams up the water. They need that water though. They've got what, 4 million people, I think, that the water system in the paper says that they capture. Give you some idea of the snow. This is a shot last June. This is a shot last week or 2 weeks ago. This is a shot last March, the same shot. So what do they get, 20, 30 feet of snow? And it all melted from, this was March 19th last year, and this is June 30th last year, same shot. So, you know, snow was what, up to here? They capture all that. Nothing goes to the ocean. This is what they live off of. And this is what Hetch Hetchy looks like full. They've dammed up, filled it up with water. Can you imagine this being another 2,000 feet lower? I don't know how many years of water they have stored in Hetch Hetchy. It's a great place to keep water because it's so large. The downside too is it's up so high. It's 8,000 feet up. Well, only so much water, only so much snow and water lands up here and can get into here. Most of the snow is, you know, from there on down. So what they do is they literally capture the water in lower reservoirs and pump the water back up the mountain into Hetch Hetchy. Because it's such a large reservoir, they've got so much big area there, they can't capture the water, so they pump the water from lower reservoirs that capture it back up into this major reservoir here. One of the projects that we're going to work on here is actually a pump station at Cherry Lake. Cherry Lake is this lake here. You can see these little tunnel shafts. This is all pumping water back uphill. Cherry Lake is here, and this little tunnel right here is our project. So we're up in the Sierras in the middle of nowhere having to do a construction job. And you'll go to these places if you're lucky. The whole system from Hetch Hetchy, as you see here, 200 miles long, 60 miles of tunnels, 5 different pump stations, treatment plants, reservoirs, supporting all these people all the way up into that's the water system from that particular reservoir. The designers out there at the Bay Area Transit System have to repair this pump station, and you only want to do it once, at least in a couple generations. So they want a 100-year design life, 200-year design life. They want to do it once and not have to come back to it if they can get away with it. So they go back and find out all this Corps of Engineers stuff on abrasion, erosion, and how to make a lifelong concrete. And they find out that silica fume is a good way to make this type of concrete. So they go to their user's manual, and they find on chapter 6 here, we have a selection of mix designs, starting points. Instead of, again, we talked about technology transfer. Instead of starting over from scratch, other people have already done it. Start off with a good idea and, you know, make it your own. Adjust it, tweak it, make it, you know, what you're going to do. So we know we need a very high strength concrete. We go to our tables here and we find that there's a couple high strength concretes here, both high-rise buildings. But that's okay. We're looking for the strength in this particular case. Come up with a mixed design here. This is all in metrics. The appendix, that's because it's FHWA, it has to be in metrics. The appendix in the book, though, is all in pounds per cubic foot, all in English units, our units. So they use this as a starting point and say we need to make a mixed design that in order to reach this design life for the Bureau, they wanted about 10,000 PSI.